Hello, this is Shivanya from VIT University. Today I'm going to talk about scanning tunneling microscope. As you can see, I put a picture on it and it's pretty much looks like the same. So, what is the working principle of a STM, scanning tunneling microscope? The quantum mechanics phenomena which defines the tunneling effect is also the working principle of scanning tunneling microscope. Tunneling effect is actually the phenomena in which a particle moves from a high potential barrier, which can't be possible in case of classical physics. Tunneling current. In a metallic specimen, there are always some Fermi energy level electron. So if you want to take them out, you have to put some energy to it, which is known as work function. So suppose you brought a just near about a few Armstrong gap. Then the air gap will act as a barrier, and electrons can easily pass from. By this way, we can see the tunneling effect, and so tunneling current can be obtained. So, components of SDM: scanning tip, piezoelectric scanner, distance control unit, scanning unit, vibration isolation system, and data processing unit. So, what are they? Let's talk about. So, scanning tip. STMs are usually made. STM tips are actually made from tungsten metal or platinum iridium alloy. These tips have one one atom on their very end, so it is very most important aspect for STM as tunneling current happens from them. Piezoelectric scanner. So what is it? The scanner tip is actually adjusted by this piezoelectric tube scanner. Piezoelectric effect is a phenomenon in which the length can be varied when you just adjust the voltage. So by adjusting the voltage, you can easily maintain the distance between the STM tip and our sample. So what is distance control and scanning unit? Position control using piezoelectric means is extremely fine. So as a coarse control, it is needed to position a tip close enough to the sample before the piezoelectric control can take over. The data processing unit. The computer records a tunneling current and controls the voltage. The piezoelectric tube to a three-dimensional map on a sample surface. Vibration isolation system. Since STM works with a very fine positioning measurement, so the isolation of the vibration is very important. Any vibration can damage the STM tip or can completely change the results. So, what are the working of it? Tip is brought close to the sample at a close range by fine control of the piezoelectric. Voltage biasing will cause electron to tunnel between the sample and the tip. Once tunneling effect is established, position and tip bias with respect to the sample can be varied and data can be obtained. Con- Two modes: constant height mode and constant current mode. So constant height mode, the voltage and the height are both held constant, while the current changes to keep the voltage from changing. This leads to an image made of current changes over the surface, which can be related to charge density. The benefit of using the constant height mode is that it is faster, as a piezoelectric movement require more time to register the height change in constant current mode. So, however, it is only applicable when the sample is real flat, about 6 to 7 Armstrong. Change in the sample will lead tip to the crash. So, generally less preferred due to the risk of damaging the tip, and the manufacturing of the tip is really very difficult to someone to do it. So, you need to take very precautions for it. So, what is constant current mode? Feedback electronics adjust the height of the voltage to the piezoelectric height control mechanism. This leads to the height variation, and thus the image comes from the tip topography across the sample and gives a constant charge density surface. This means contrast on the image is due to the variation in charge density. So merits and demerits. STMs are versatile. They can be used in ultra high vacuum air, water, and other liquids and gases. STMs give three-dimensional profile of a surface which allows researchers to examine a multitude of characteristics including roughness, surface defects, and molecular size. Lateral resolution is very high, of 0.1 nanometer to 0.01 nanometer of resolution in depth can be achieved. Disadvantages: it's very expensive. It needs specific training to operate effectively. STM needs very clean surface, excellent vibration control while operation single attempt. Thank you.